so this problem asks us to find the critical points and the intervals on which the function is increasing or decreasing. Also, determine the type of extrema, maximum or minimum, at the critical points. And our given function is y equals x to the third minus 12x squared. Okay, that's our f of x. So this is kind of a mouthful, right? We just got a lot going here. So what we're going to do is find the critical points. So we do that on every problem, basically. We're going to find the intervals of increasing or decreasing of our function, and we're going to determine the type of extrema. Okay? So, but this isn't anything we can't handle, or anything that sign analysis can't handle, right? So the first thing we're going to do is find those critical points, and we need our f prime of x to do so. So if we take the first derivative of this function, we get 3x squared minus 24x, okay? So we're going to factor out a 3x from both terms there. So we get an x minus an 8, okay? So here this function is continuous. It doesn't not exist anywhere. So what we're going to have to do is set it equal to 0. So f prime of x is equal to 0 when x is equal to 0 or an 8, all right? So these are our critical points here. So we found those. First part down, completed. Okay, so now let's do our sign analysis on the next slide. So here's our f prime, well, I'll just write it over there. So f prime of x is equal to 3x times x minus 8, okay? So now that we have that and we have our critical points, let's set up our number line. So here's f prime, that's what we're analyzing. So here's 0, and here's 8. So let's pick some easy values. So in between we just have a 1. Let's say here's a -1 and here's a 9, okay? So now let's plug those in, these three values, and see what signs we get out of them. So f prime of -1 is going to equal 3 times -1, and then we have a -1 minus 8. So this is going to be a negative value on the outside and a negative value on the inside. So that's going to turn out to be a positive number, right? So we have a positive number over that -1. And then let's say we plug in a positive 1. We have 3 times +1 times +1 minus 8. So this is a positive times a negative, which is a negative. Okay, so that's a negative value here. So we do see a sign change. And that last one, if we plug in a 9, we're going to get 3 times +9 times 9 minus 8, which is a 1. So this is going to also turn out to be a positive number. So we're back in the positives. Okay, so now that we have that, that was basically the hard work. So now we're going to look at this number line and see what we can make of it. So we'll see, let's look at this critical point, this 0 and this 8. So first we'll look at 0, and we see that the first derivative changes signs from positive, so increasing to decreasing, right? So positive to negative, so that means we're at a local maximum here. So maximum at that critical point. And then let's look at 8 now. We see that our first derivative changes from negative to positive, right? So that's going to be decreasing to increasing. Okay, so here we're at a minimum. Minimum there. I can't write it in. There we go. So minimum. And furthermore, so we identified the type of extrema, right? So at 0 we have a maximum, at 8 we have a minimum, and we also had to find the intervals of increase or decrease, right? So wherever we see a positive sign, basically, that's where our function, so the positive sign means that our first derivative is positive, so that signifies an increasing function on that interval. And this one, this negative sign, denotes a negative first derivative, so that means we're decreasing here. And then lastly, we see a positive sign again, becomes positive, so we're increasing again. All right, so let me draw on the next slide a little cleaner version of that. So here's our f prime, all right? There was a 0, and here's our 8. So we had a maximum here and a minimum here because we went from positive to negative and back to positive, all right? And our test points were -1, 1, and 9, right? And I said this is increasing, this means decreasing function, and this means increasing f of x, or that's supposed to be a c. Okay, f of x, all right? So our intervals of increase, so let's do that first. So this interval here, the way we name it is negative in infinity to 0, so up to that endpoint, right? And then we'll draw a divider line here. And then also, so this is increasing, right? So this was an increasing one, increasing interval. And also increasing is this positive one over here. So the way we name that is 8 to infinity. Those ones kind of look funny. But anyway, so both of these intervals are increasing. the only decreasing one is this middle guy, which we name that 0 to 8. So this one is our decreasing interval, okay? All right, so then the last thing that we had to do was identify or determine the type of extrema, right? So at x equals 0, we had a local max, local maximum, right? And then at x equals 8, we had a local minimum. So we'll write that in there. Okay, local minimum. Okay, and that's pretty much it. This is the summary of our sign analysis for that problem. All right, so that wraps it up for the video on the mean value theorem and monotonicity. I hope that helps, and good luck on your homework.